In the previous video, we discussed about syllabus for engineering thermodynamics, content of first module, that is basics of thermodynamics. Okay, and we studied the definitions for engineering thermodynamics with examples, and we studied applications of thermodynamics, and also we studied the scope for the thermodynamics in our day-to-day life. These all concepts we have discussed in the previous video. Now I will move towards next concept, next topic, that is macroscopic and microscopic approaches of thermodynamics. Okay, so we discussed what is thermodynamics. Thermodynamics is nothing but what? Thermodynamics is nothing but interaction between energy and system and its effect on the system. When the energy is going to interact with the system, the properties of the substance is going to change. Because of this, there is a change in the state of the system. If the properties of the system is changed, then what happens? We are going to get a work. Hence, there is an interaction between the science and technology which deals with the interaction between energy and system. Hence, the properties of the substance is changed. Then there is a change in the state of the system. Then we can get the work. This is the thermodynamics definition we already studied. Okay. Then the properties of the thermodynamic system or study of thermodynamic system can be done in two ways. One is macroscopic approach, another one is microscopic approach. What is macroscopic approach? That we can see here, dear students. The macroscopic approach or a study is nothing but what we are doing. We are considering in macroscopic approach is the approach of thermodynamics in which certain quantity of matter or group of molecules are considered for the thermodynamic study. But here we are not at all considering the behavior or characteristics of the individual particles or individual molecules. That study we can call it as a macroscopic approach. Macroscopic approach is a thermodynamics approach in which group of molecules or certain quantity of matter is considered for the study. Okay, and this approach is simple and it requires only few variables for the study. And this macroscopic approach deals with the measurable macroscopic variables like pressure, volume and temperature. Then second approach is microscopic approach. In this microscopic approach is a thermodynamic approach in which behavior of individual particles or characteristics of individual particles and their interactions are considered for the thermodynamic study. That study we can call it as a microscopic approach. Here we are considering behavior of individual particles for study, and it deals with the macroscopic properties like molecular velocity, position and energy. Okay, now what I will do to understand this macroscopic and microscopic, what I will do, I will consider in a system. Okay, assume that the system is consist of some matter in it. Okay, that matter you can take gas or liquid or solid, anything. So combined together I will call it as a system. Okay, the properties of the system or analysis of the system can be done in two ways. One is macroscopic, another one is microscopic. What is macroscopic? If I consider group of molecules or certain quantity of matter for study, certain quantity you are considering here now, certain quantity, I will write it here, certain quantity of matter or group of molecules consider for study, that approach or study we can call it as a macroscopic approach. If I studied the thermodynamic system by considering individual particles or individual molecules, then that study we can call it as a microscopic approach or microscopic study. Here what I am doing in microscopic study, I am going to check the properties of the individual molecules. What are the properties? Those properties we can call it as a microscopic properties. What are those? Position of the individual particle, that is X, velocity of the individual particles, that is V, and energy of the individual particle, that is E. Whereas in macroscopic approach, we are going to study the macroscopic properties of the system. What are the macroscopic properties of the system? That is pressure, volume, and temperature. Okay, so if you consider group of molecules or certain quantity of matter is macroscopic approach. If you consider individual molecules for study, that we can call it as a microscopic approach. How it is? So I have taken one example here to better understanding that you can see here, dear students. I have taken a system. Okay, it consists of a gas. Okay, it consists of a gas. So the thermodynamic study can be done here on this system in two ways. One is macro MA, another one is micro MI. Okay, for short, what I will do to do the analysis, I will consider certain quantity of matter or a group of molecules per study. If I am considering certain quantity of matter or a group of molecules for thermodynamic study, that approach or study or way, I will call it as a macroscopic approach. That I will call it as a macroscopic approach. What I can measure in macroscopic approach? I can measure the macroscopic properties. What are the macroscopic properties? That is pressure of the gas, volume of the gas, temperature of the gas, and moles of the gas. That approach we can call it as a macroscopic view or macroscopic approach. So if I want to measure the if I consider for the study, if I consider individual particles, then that approach we can call it as a microscopic approach. If you are doing the thermodynamic analysis or thermodynamic study by considering individual molecules, then that approach we can call it as a macroscopic approach. In macroscopic approach, what we are doing, we are going to determining the proper position of the individual particle, velocity of the individual particle or a molecule, and mass of the mass or energy of the individual particle. So if you are measuring the properties of the system, or if you are doing the study on the system by considering individual particles and you are measuring the microscopic properties like position, velocity, and energy of the individual particle, then that study we can call it as a microscopic approach or microscopic view. Okay, so this is the difference between macroscopic and microscopic. In macro, we are going to consider certain quantity of matter, but when it comes to micro, we are going to consider individual particles for the study. Okay, as I told, you can see one more diagram here now. Macroscopic means what? It will give the broad view on the system by considering certain quantity of matter, but microscopic will give detailed study by considering the individual particles in the thermodynamic study. Okay, fine. Okay, fine. Now to understand better, what I will do, I will consider some examples here now. So what I will do here, dear students, I will take in one application or example, that is IC engine. Okay, now IC engine, that too I will take in a piston and cylinder arrangement. Okay, I will take piston and cylinder arrangement. Okay, fine. That cylinder is filled with the gas actually. So the cylinder is filled with the gas. So if I want to measure the properties of the system, or if I want to do the study on the properties of the system, or if I want to do the study on thermodynamic system, that can be done in two ways. One is macroscopic study, or either it in microscopic study. What is macroscopic study? What I will do, I will take certain quantity of matter or group of molecules for study. If I am taking group of molecules or certain quantity of matter per study, that we can call it as a macroscopic view or approach. In macroscopic approach, we are going to measure the pressure, temperature and volume. Hence this properties we can call it as a macroscopic properties. Okay, what I will do, I will take a thermometer example. In microscopic, I will take a thermometer. I will put a thermometer into the cylinder. Group of molecules or certain quantity of hot gases, they are going to interact with the thermometer and they will give them reading of temperature. That property measuring by considering group of molecules or certain quantity of matter is nothing but macroscopic approach. One thing. So what is microscopic then? By considering individual particles or individual molecules and measuring the properties of the individual particles, like position of the particle x, velocity of the particle v, then energy of the particle E. Measuring these kind of properties in thermodynamic study by considering individual particles, that study we can call it as a microscopic approach or microscopic view. Okay, this is one example. You can see here now, when it comes to macroscopic, it is simple and it is easy. This method we can call it as a classical method. But when it comes to macroscopic, measuring the properties of individual particles or molecules or gas molecules in the system is difficult, and it requires a number of variables, and it requires a number of statistical equation. Hence this approach we can call it as a statistical approach or statistical method. But when it comes to macroscopic, it is using a small less number of variable per study, and it is using simple mathematical equation per study. For that purpose we can call it as a classical approach. Okay, fine. So we know what is macro. Macro in simple terms, big. Okay, macro in simple term, it's a big, whereas micro is nothing but what? Small or individual we can call. Small or individual. Okay, big or whole we can take. Whole or certain quantity of matter. Okay, fine. So we can take one more example here, dear students. If I want to measure the temperature of the human body, assume that this is a system. Okay, you can do study on this human body or a system in two ways, macroscopic and microscopic. What is macroscopic? That you can see now. What you will do, whole body in the hand itself, I will take a small area. Okay, on that area, what I will do, I will put a thermometer. When we are putting thermometer in a small area, that means what? Only few area, small area is going to interact with the thermometer. That means what? Group of molecules or certain quantity of blood cells, they are going to interact with the temperature, interact with the thermometer. Hence, they are going to give the reading of temperature. Measuring the temperature of the human body by considering group of blood cells or certain quantity of blood cells, then that study we can call it as a macroscopic approach or macroscopic study. You can take one more approach here now. Means measuring the properties of the individual blood cells which are flowing in the human body. What that approach we can call it as a microscopic approach. In microscopic approach, what we are doing, we are going to determine the position of the individual particle or a blood cell, velocity of the blood cell, and energy of the blood cell for an individual particle. Measuring the properties, microscopic properties like position, velocity and energy of a individual particles in human body or a system is nothing but what? Microscopic approach. Is nothing but what? Microscopic approach, dear students. Okay, fine. To understand better, I will take some live examples. Okay, so there is a 25 kg of rice. Assume there is a 25 kg of rice or any grain bag you can take. To check the quality of that rice bag, what we will do, we will take certain quantity of rice. Okay, a number of molecules, rice particles we can take. If you are considering certain quantity of rice particle per study, that is nothing but what? Macroscopic approach. In that, if you are taking only one or two or individual rice particle to check the quality of the rice, is microscopic approach. Macro means what? You will take some sample, certain quantity of rice. We will take 5 gram or 10 gram. Then you will check the quality of the rice. If you are checking the quality of the rice by considering group of molecules or certain quantity of matter or certain quantity of rice particles, is nothing but what? Macroscopic approach. If you are considering individual rice particles and you are checking the quality of the rice, is nothing but what? Microscopic approach. This is one of the examples we can take. One more example, if you want to check the rice is cooked or not, the rice is ready or not, that can be done in two ways. One is macro, another one is micro. Macro means what? You will take certain quantity of rice, and you will check whether rice is ready or not. If you are checking the rice is whether it is ready or not by considering certain quantity of rice, that is known to be macro. If you are considering individual rice particles, you will take a individual rice particle, you will press it, you will eat it, then you will conclude that rice is ready. If in the second case, what you done, you consider individual rice particle to check the quality of the rice. If you are considering individual rice particle to check the quality of the rice, is nothing but microscopic approach. Individual particles. Here also you can take a popcorn. If you are eating popcorn and tasting, you can do it in two ways, macro as well as micro. Macro means what? You will take together certain quantity of popcorn, 4 or 5 at a time you will take and you will eat it and you will taste it. That is macro, certain quantity, that certain popcorns you have taken at a time. But second way, you will take only one popcorn and you will eat and you will taste it. That is nothing but what? Micro. Okay, micro means what? Considering individual particle for study. But here, to understand, I am considering eating examples for tasting and all those things. So to understand macro and microscopic better, I will take one more example, that is cricket ground. Assume that team A won the match. Okay, the result is team A won the match actually. So this I can express in two ways. One is in macroscopic way. Second one is microscopic way. How it is? Assume that, dear students, there are 11 players, they have played well and they won the match. Then what you will do? Because of the whole team, because of all 11 members, they played well, bowling, batting, everything, fielding, everything, all players they played well. Because of all members, because of whole team, we won the match. If you are considering group of molecules or whole team, is nothing but what? Macro. Second case, because of that batsman scored 180 runs. Because of that individual performance, because of that person, we won the match. So you are in the second case, we are considering individual person. Because of the individual person, because of this is better performance of individual person, we won the match. If you are considering individual person, that is nothing but what? Microscopic approach or microscopic study, that we can see. These are the live examples to understand better. Okay, fine. While explaining a macroscopic approach, I told there are some macroscopic properties. What are the macroscopic properties? Those are pressure, temperature and volume. What is pressure? Pressure is nothing but what? Pressure is nothing but what? P is equal to force per unit area is the pressure. Unit for pressure is what? We can see F by A. What is the unit for F? That is Newton. Area for unit for area is meter square. Hence the unit for pressure is Newton per meter square. So how it is then? You can see here now. You can take a rice cooker. Now already almost rice is ready. The steam is what it will do. It is going to exert some force. That force exertion is represented by F, and that force is going to act on the vessel at a particular area. That area is represented by what? A. The force acting on a particular area is nothing but what? Pressure. So pressure is force acting on a particular area is pressure. Okay, fine. Similarly, you can take a boiler. When the water is converted into steam, that steam is going to put a force on a pipe here. Now assume that there is a pipe, some force is going to exerted by the steam, that force is going to act on the pipe, that at a particular area, that area is represented by what? A. The force acting in a particular area is pressure, so pressure is equal to F by A. Okay, like that you can take a number of examples. You can take oil pump, you can take a body pressure, you can take a stress on body, you can take a tire and a pressure. These are examples for understanding the pressure. Okay, now understanding the temperature, this is also one of the important macroscopic properties. We will tell, right, weather. How we are telling weather? Temperature is nothing but what? Measuring the hotness or coldness of the system. So whether you will tell whether the climate is cold or bad, cold or hot. The measuring hot or coldness of the system or weather is nothing but what? Weather checking. You can take hot coffee, whether coffee is hot or cold. On what basis we are telling? Temperature. We can take baby tears. Baby tears, when it is coming out, right, it is hot actually. If it is hot, then you can say that temperature is more than this thing. Okay, measuring the some temperature of the substance, measuring the temperature of the human body during the health checkup. There what they will do, they will check the temperature of your body. That means what? Whether you are cold or hot. Like that, global warming, temperature play a very important role. AC, temperature play a very important role. A body temperature, and also a temperature play a very important role in the photosynthesis also. Okay, now understanding volume. So volume, you can understand, dear students, when we are going to put a compressed air into the balloon, then balloon is going to expand. If the balloon expands, then what happens? We can say that volume is getting expand. That means what? Volume is increasing. One example you can say, you can take a bucket. When you are going to pour water into it, you can water or any liquid you can take, then height of the water is getting increased. That height is represented by what? H. That bucket having an area, that area is represented at A. If the H increases, then what happens? The volume is going to increases. That means water level is increasing, means volume is increasing, where volume is the product of area and H. If H increases, volume increases. If A increases, volume increases. If both A and H increases, volume is going to increase. Okay, one example. You can take a rice or grain bag. When we are going to fill the rice or grain into the bag, the level of the rice or grain is going to increase. Okay, that increase in height is represented by notation H, and that bag having an area A, then volume becomes A into H. As the H increases, volume is going to increases. You can take a hot air balloon also. Hot air balloon also you can take an examples. You can take a tire. When it is punctured, right, it is a flat actually. Once it gets ready, when you are going to fill air into this, right, the volume is going to increase. Okay, so next, volume is nothing but what? Area into thickness or area into length or height you can take. You can take a rice cooker, you can take a popcorn. When we are going to fill popcorn into the popcorn bucket, right, the volume is going to increase. We can take air balloon, we can take grain. Like that we can take a number of examples for. We will study the difference between macroscopic and microscopic approach. Okay, macroscopic is nothing but what? This is a thermodynamic approach in which certain quantity of matter is considered for the study. But here individual molecules are considered for the study. Okay, and this macroscopic approach we can call it as a classical approach. This is, we can call it as a statistical approach. Why it is statistical approach? Because it is using n number of variables for study, and also it is going to use statistical equation or statistical equations for study, that is known to be statistical thermodynamics. But here macroscopic is the study in which only few variables are considered for study, and it is a simple, and it is going to use simple mathematical equation for study. Hence we can call it as a classical thermodynamics. Okay, as I told, macroscopic approaches is going to use only few variables, but here large number of variables are required for study in microscopic approach. So here with the in diagram I tried to show you the difference between macroscopic and microscopic. Macroscopic application are more, and it is a simplified method, and it focuses on the whole system. Macroscopic, but when it comes to microscopic, it is a specific phenomena oriented approach, and it will give the detailed interaction between individual particles, and it deals with what particle level. Okay, fine. Now here are some more important points to remember, or here are some important difference between macroscopic and microscopic approach. So in macroscopic, it deals with what in macroscopic approach, it deals with the macroscopic properties like temperature, pressure, volume and internal energy. But here in microscopic, it deals with the microscopic behavior of the molecules. Okay, and it is going to consider certain quantity of matter for study, but here individual particles are considered for the study in microscopic approach. Here it requires few variables for study, but here it requires more number of variables for this study. When it comes to microscopic approach, it is going to consider microscopic properties. Those are molecular velocity, positions and energies. Okay, and it is observation oriented approach, macroscopic approach, but it is statistical approach. Okay, so it is a simple one. Macroscopic is a simple one, and it is a complicated, and it uses simple empirical equations or mathematical equations for study, but it uses statistical equations for study. Hence microscopic approach we will call it as a statistical approach or statistical thermodynamics, whereas if it is using simple equations for study, that we can call it as a classical thermodynamics. And this is developed, macroscopic approach developed earlier historically, but this microscopic approach is developed later than the classical thermodynamics. Okay, this is the difference between macroscopic and microscopic approach. Okay, so today I am going to end in this particular session. Okay, dear students, please do like, share and comment and subscribe my YouTube channel. It will help me to make more videos related to engineering subject. Please encourage me by subscribing my channel. Thank you one and all.